So last thing we're going to look at on rotations is actually being given the rotation itself and having to write the rule. So if I look at this picture right here, I can see that the original figure is P, H, K, B, and that the image is P, H, K, B. And I know that's the image because they have the apostrophes to indicate that each of these points is the image of the original point. So what I have to do is I have to figure out, how did we map this one image to this other image? How did we move this image? Well, I'm going to take the original point, one of the originals, and I'm going to try to stay away from zeros if I can, because zeros are not really going to help me, because a zero, when it changes, is still going to be zero. I also want to try to avoid double numbers. So if you have a zero for either one, don't use it. If you have something that's like a 2, 2, try not to use that, because that's not going to give you any feedback as far as if you've switched numbers and switched signs, because when you switch them, they're going to be the same as you were when you didn't switch them. So let's look at number 7. I'm going to pick point P. Point P is located here on the original. This is my original right here. Okay. Point P is located at 1, -3. So I'm going to look at the original. After the original, I want to look at the image. So I've got the original, and then I have the image of P. The image of P right here is located on the image. And that particular one is at 3, -3, -1. So the question is, what rule did I use to go from 1, -3 to -3, -1? Well, I'm going to actually write this as xy. I'm going to make 1 the x, -3 the y, and then I'm going to try to figure out how I got from here to here. Well, first of all, the 1 and the 3 did what? They switched places. So I know that I'm going to have a yx of some sort. The y and the x values switch places. The 1 went to -1, which means that became an opposite. Because that was 1, and when I put it over here it became -1, that means I've got to change it. The -3 stayed a -3. So my transformation rule is xy goes to y, comma, opposite of x. Now what is that rule? What does that represent? Well, that represents a rotation. Okay, that represents a rotation of 270 degrees counter or 90 degrees clockwise. So that's all I did to use the rule. So let's look at number 10, and let's try to figure out the rule for number 10. For number 10, my original image is S, X, U. And again, I don't want to pick a 0, I don't want to pick a double, I want to pick something that'll help me out. So let's pick U. U is at -2, -1. Okay. So I'm going to go on my image now, and I'm going to look, this is my image. I'm color coding it so you can see the transfer to U prime, which is my image of U. And U prime is 2, 1. 2, 1. So the question is, how did I get from the pre-image U to the image U prime? Well, let's put them together. I went from -2, -1 to 2, 1. So let's write a rule for that. Let's say the -2 is x and the -1 is y. Well, did the x and y switch places, 2 and 1? No, they didn't. So I'm going to have x and y in some capacity. But -2 changed to +2, which means we took the opposite. So there's a negative in there. -1 changed to +1, so we took the opposite. So this is my rule. I went from xy to -x, -y. And if you look that up, that is a rotation of 180 degrees. And we don't have to indicate whether that's clockwise or counterclockwise because 180 is 180. So that's how you do the writing the rules for the rotations.